Hello. Good morning. Can you hear me? Can somebody say yes or no?
Yes. Good morning. You're coming in loud and clear.
Yeah. Okay. Thank you. Thank you very much. I hear you also very well. Any question about this little program that we have here on the screen?
So is all of the code pretty much that we're going to be writing going to be like this? Like,
Pardon me? Can you repeat the question, please?
so for the assignments and stuff and the tests, is it basically going to be on?
No. This is just a little demo to read the code that is without studying language. You know, can we understand what is here or not? So nothing different from that. We are not interested in Pascal, but at the end of Reader, there are several Pascal programs that show rather explicitly the power of that language. It is a rather powerful language. It has plenty of nice things, particularly you have one program that is showing the anatomy of recursion. It is practically displaying recursive calls. That's very good for studying recursion. And another program shows cluster analysis, which is based on an array of sets. So you have an array of objects, and each object is a set. And Pascal can do that because it supports sets. So it is a very interesting program that is showing the power of Pascal, because you solve the problem to have an array where each component in the array in a set is a set. And this is very easy to do in Pascal. Of course, in languages like C++ and similar that do not support set, this is tragically missing, and you have to write very complex code. And in Pascal, you can do it very easily. So let me go through this program very quickly. So what's this program doing? Well, nothing. It is just computing arithmetic series. So 0 plus 1 plus 2 plus 3 plus 5 plus whatever is this value here. And we want to make this sequence of arithmetic progressions. And we ask the user, enter how many of them you want to do. So here is 10. So the prompt is enter a small positive integer count, so 10. So you have 1, 2, 3, 10, these lines of code. So going from 0 through 10 is 55, the sum of all these numbers. So how to write that? The first, what you can see here, that Pascal is a program that starts with the keyword program. So program is the beginning of program, and this dot here is the end of program. So program and the dot are left and right parentheses. Inside is the program. Now, you have to define all variables that you intend to use. So you say variables, var, and say nij sum. They are type integer. So this is the list of these variables, then colon, telling what is this. Can be integer, can be real, can be whatever you want. And then the whole program is written as a sequence that starts with word begin and terminates with word end. Okay. What I didn't do here, I usually do that. This begin, since this is case insensitive, you put here capital begin and here capital end, so that you know that this is beginning and end. And then inside, you put lowercase begin and end, so that you differentiate them. If it is case insensitive, that you can play with uppercase and lowercase. So outside, you put uppercase, and then inside you put capitalized, begin with capital B, and then with capital E, or completely inside begin end, because you can write it any way, but then you see where is the beginning and where is the end. It is very good for documentation. Okay. So what I have to do now, I have to read this value 10. I have to give this prompt and put this value 10. So this is done here. Can somebody tell me why to use this repeat until loop? What's the reason for that?
This is used to make sure the input integer is larger than 0.
Yes, bravo. For what reason? Whenever you ask your user to enter a value, if you are writing this program for yourself, then you simply say prompt and you enter the value. Okay. But if you write for somebody that you don't trust, these people can play games with you and say, you want positive integer. Here is -13. Let me see what's going to happen. So you must not permit to break your program. Therefore, I usually close my users in repeat until loop. And you are not going to go alive outside of this loop unless you give me correct input. Okay. So I'm asking you, give me enter small positive number, and I read that, and then I'm not going to let you out unless you give me positive numbers. So no zeros, no negative numbers, etc. Then you can say, if you have somebody who is going to say, you want the number, I'm going to put you 10 written as TEN with characters, trying to break your program. Well, if you want to prevent that, then you have to read this as a string and convert the number yourself. So if you don't trust your user, and if you expect somebody who will try to break your program, you must always lock your user inside repeat until loop and keep it inside incarcerated until gives you correct input. So depends, do you trust or not trust your users? But there are various people, and sometimes it's good to keep them inside this loop to make sure that you have correct values. Now, once you have correct number, you have to put n line like this. And one thing that you see here, that I don't have to compute all these values in each line. For what reason? Simply because, Peter, go ahead, you have a question.
Oh, sorry about this. So what does a semicolon mean? Does it mean the end of the sentence or something?
What is the question? What this dot means, or what?
What does the semicolon mean?
What I cannot understand the first word. What does the
semicolon mean?
Semicolon.
Yeah.
Semicolon. Yeah. Very good question. Semicolon means separator between two statements. Separator, which means, look at this. I have here a loop, begin, end. And then when I write here, last one, right line, this sum, there is no semicolon here because it is terminated with end. So semicolon is a separator that separates this statement, sum is sum plus I, and this right here. Okay, so this separates them. This is not the terminator of the statement. You don't have to put it here at the end because there is nothing after that. It comes end. So begin, end, and same here. Begin and this end. After this right line, there is no semicolon. So this is the language that uses semicolons to separate objects one from the other. So imagine, for example, that you are writing swap statement. So you are going to say begin, and then A equals B, T equals A equals B, B equals T. So between these three statements, you are going to have two semicolons, but not at the end. At the end, there will be no semicolon. Okay, so that's what semicolon means. Is that okay?
Yeah, thank you.
Okay. Also, if you want to ask questions, you just unmute your microphone and say, I have a question, and then I will, you don't need to raise hand. If you want to raise hand, that's perfectly okay. Nice, thank you very much. But if you stop me in any way you want, that's perfectly okay also. So we want to see how to compute these values. One thing that you see is that each of these lines use the result from previous line. Because, for example, if I want to add this 1 to 3, 1 plus 2 plus 3 plus 4 plus 5. I first compute up to 4 and then add 5. So practically this 15 is previous result 10 plus 5. And then 15 plus 6 is 21. And then 28 plus 8 is 36. So I don't have to compute the whole sum. So I'm going to compute this sum, which is assigned 0 at the beginning, by only adding I to sum where this I is a line number. So for I is 1 through n, I'm going to say sum is sum plus I. So I'm computing this result. And then what you see here is that Pascal is language that has write statement that is writing prompt, for example. But if you want to write a string, you have to put it under single quotes. So it is not using double quotes like many other languages, but it is using single quotes. Same is Fortran, by the way. And then here you have that I write 0 because I always start with 0. And then after that, I have this loop that is going with j from 1 through I to put all these components here. And then when I write that, I have here write this plus sign and then this value j. Now, one thing that Pascal gives you the possibility is to say how big is this field where you want to put this j. So I want to put this j in the field that has 2 characters. So when I put this plus, after that, there are going to be 2 characters. And after that, I have 2, 3, 4. And if I have 10, that it is going to be no space in front of that. Then after that comes equality sign at the end. And then I print the sum with 4 characters. So if I have here 55, I have 2 spaces in front of them. So Pascal tells you display this, but in 4 character field, which is a kind of handy. You can also say how many characters you want to have before and how many after the decimal point and stuff like that. So this little example here shows a procedural program in a language that we have not studied, but you can perfectly understand what's going on if you understand what has to be done and how to do it and what is idea behind that. Also, you have to say, I'm going to have input and output. That means I'm going to read using read and write using various write statements. So you can include this library. So you say program is called count, but it has some input and some output. If you have files, you have to put them too as well. Okay, now an example that is more complex in Pascal, and this is taken directly from the definition of language. And you have first definition of what is compound statement. So this is whatever is between begin and end. And of course, this double quote is used in Pascal to say this is a keyword, and therefore we have begin, and then statement sequence, and then end. Now we have to say what is the statement sequence? Well, the statement sequence is statement, semicolon, statement, semicolon, statement, semicolon, statement. And whoever asked about semicolon a minute ago has now also an answer to that question, because the sequence is statement not terminated by semicolon, but separator between this statement here and this statement here is the semicolon. And this repeats any number of times. So these braces tell you that this semicolon statement can repeat any number of times. Therefore, semicolon is separator between this statement and this statement here. And of course, if you have more of them, in front of each of them will be semicolon. Is this now clear what semicolon means? Semicolon in some languages is separator. In some languages, it is terminator. It terminates the statement. Now, each statement can be simple statement or structured statement, but this is optional. And you have that simple statement or structured statement can be labeled. So if you have the situation where this statement is destination of some jump, then you might have here label, which is numeric label, like for example, 100 colon. That means that somebody will use the statement go to 100. And this is going to be jump from any position inside your code to this labeled statement that has label 100. Simple statement can be empty, or can be assignment, or can be procedure, or can be go-to statement. Now, one thing that is nice in Pascal, in EBNF, that each construct terminates with 0. So you have here, when you want to define empty statement, you say empty statement equals and put dot after that. So this object should be between equality and this dot. And between equality and dot, there is nothing. Therefore, empty statement is the absence of an object. It is empty. It has nothing inside. And it is a nice way to define the empty statement. Assignment can be variable or a function identifier, and then you assign the value, and then you have expression. So assignment is variable expression. Variable, for example, x equals 2 times a plus b. 2 times a plus b is an expression. Now we have to define what is expression. And this is very difficult because expression can be whatever you want, and each component in expression can be substituted with an expression in parentheses. So if we want to define expression, we have to say, well, expression is simple expression, and then it can be, after that, relational operator and another expression. So simple expression is A, relational operator greater, simple expression B. So A greater than B, and that can be logic expression, A greater than B. Now, what is relational operator? It can be equal to, not equal to, less than or equal to, greater than or equal to. And one beautiful thing that we have in Pascal, and that is tragically missing in all languages like C, C++, and similar languages that do not support sets. So in is set belonging. Practically, in majority of programs, you have the need to have collections of objects. Well, collection of objects is a set. So it is very, very useful if you can have the possibility to have the check whether an object belongs to a set. And this set belonging is defined as in. And in is this symbol that looks as epsilon in mathematics. You know, this symbol for element belonging to set. Well, this is here defined as in. So one of relational operators. So you can say, for example, if A belongs to set 1, 2, 3, then do something. If it's not belonging to set 1, 2, 3, do something else. This is very comfortable because if you don't have sets, then you have to say if A equals 1, or A equals B, or A equals 3, or whatever else, you have to put a logic expression and write a lot of code as opposed to say if X belongs to 1, 2, 3, which is much more readable, better understandable, etc. So this is a very nice thing that Pascal has, and this is the set data type and then set belonging as operation, which is very frequently used. Now, simple expression was that it has an optional sign, and then you have term plus term. Adding operator can be plus or minus, but can also be or, logic or. So it is term plus, minus, or another term. So if it is or, then must be logic operator. So this can be logic expression. This can be another logic expression, and then you have or in between. For example, if X is less than 15, or X is greater than 55, perform something. Okay, so you have term plus term or term or term, and you can have any kind of repetitions here because this repeats any number of times from 0 to more. Then after that, you have to say what is term. Term is factor multiplied by factor. So you have that multiplying operator can be multiplication. This here is not integer, but real division. So if you use this operator here and divide, for example, 1 divided by 4, you're going to get 0.25. If you use this div, then 1 divided by 4 will be 0. This is integer division. Intentionally, Pascal does not want to support overloading because overloading is considered something that is for beginners not particularly convenient because you have to explain why something happens. So they wanted to separate all operators and to have them different. Multiplying operator can be modulus or and. So going from expression, we come here to this product of various terms. I have also to mention that if you have this kind of construct, then whatever is the lowest priority should come first. Whatever is the highest priority has to come last. So you are going to see that on next Wednesday when we study a little more of syntax and semantics, but this is what happens when you have this order of this line and this line. It is practically defining associativity. Associativity, who is going to associate with whom. So first put additions and after that multiplication. That's the bottom line. Now we have here factors. Okay, so what is factor now? Factor can be expression in parentheses. And so by defining expression, I define expression with another expression here. Factor can be unsigned constant, identifier, variable, set constructor, function designator, not factor, etc. But it can be expression in parentheses. We are not interested in Pascal here, but I'm just taking things directly from language definition to see how recursion works. So this expression is substituting each factor as possibly another expression in parentheses. And then you have to define what is unsigned constant, what is function designator, what is actual parameter list. So you have parameter, comma, parameter, comma, parameter, comma, parameter, which is in function, because function designator is function identifier, for example, f, and then in parentheses, you have actual parameter list. So this is here parentheses. So you can have f of a, comma, b, comma, c. So this is function of 3 variables. For example, you want to compute the area of triangle and say area, and then in parentheses you have a, comma, b, comma, c. These are sides of triangle, and your program computes the area. So this is actual parameter list. So what can be actual parameter in function? Again, an expression. So you have that expression is a rather complex thing and depends on language how complex this can be. So here is an example of input statement in C++. So in C++, you have input statement that is C in, extract variable 1, extract variable 2, extract variable 3. So you can say input statement in C in, and you have input list. What is input list? Input list is extract variable. Or previously defined input list, extract another variable. So you can say C in, extract A, extract B, extract C. So extract 3 variables from the input stream. What is variable? Well, variable is an identifier, but identifier can have list of indices. So it can be identifier with or without list of indices. So identifier is letter followed by characters. character is letter or digit, letter is A, B, C, digit 1, 2, 3, and list of indices that we have here can be empty or can have a single index or 2 indices or 3 indices, etc. What is index in C++? It must have pair of brackets, okay? And inside is an expression. So I'm doing this to show how to define expression. So to define expression, we have that expression same as before. So now we are copying this from here, where we define expression. We are copying the same, but in BNF. So expression is term, addition operator term, or an expression addition operator term. So you have something plus something plus something plus something. These are terms. What is addition operator? Plus or minus, of course. And what is term? Pay attention, that cannot be empty. Plus or minus are operators that are either adding or subtracting. Term can be factor, multiplication operator, factor. So multiplication operator is times or division, and then a factor is number or variable or function call or expression in parentheses. So each factor can be expression in parentheses. And here is this expression in parentheses, same as this one here. Number can be integer or real. Integer is sign with digits, and sign is plus or minus or empty. Digits are single digit or some previous digits when you append one digit, either on the right-hand side or left-hand side. Now, what is real? Real can have an optional sign, and then you have digits dot digits. So 1.5. 1.5 is one real number. Or you can have sign digits dot. So -3 with dot. So this is going to be -3 as a real value stored in memory. Or you can have sign -0.3. So -0.3, or you can have, of course, a digit followed by digits like here. So 3.3 or 3 point or 0.3. You can have all this as a real number. What is function call? Because we had to have function call here. Now I have to define what is function call. Function call is identifier of function, for example, logarithm. And here you have list of expressions. You can be a single value, like logarithm of 5. That's 5, fine. But you can have here an expression. For example, logarithm of 5 times x, which is an expression. Theoretically, you can have that list of expression can have a single expression or multiple expression. So going from definition of expression, we came here that again, each component can be substituted by expression. And this is something that is characteristic of expression, which is a rather complex thing because it can have whatever you want. All functions can be inside, and functions can have variables, and variables can have indices, and each index can be another expression that also has additions, multiplication, etc. And compiler must be able to compile that. Now, let us see something that is simpler. Go ahead, question.
On the test, are we going to have an option to choose BNF versus extended BNF, or are we going to have specified questions?
It is going to be explicitly in this way.
Okay, thank you.
It says, let me show you, in this way. This is taken from exam. Write BNF, EBNF, syntax diagram, and parenthetic notation of the syntax of exponential real numbers. Exponential real numbers are exemplified here, 1, 2, 3, 4 times 10 to minus 12. And then you have to write solution using BNF, then solution using EBNF, then solution using syntax diagram, and then solution using parenthetic notation. Okay? So the answer to your question is that it is always very very clearly specified what has to be done. Okay? Where are we now? Here. Here is another simple assignment that also be on exam. It says, write syntax of integer divisible by 10. Okay, so it is going to tell you which notation that you use. So what are integers divisible by 10? These are all numbers that have 0 at the end. So it is minus 10 or 0 or 20 or 30 or 40. Now, if you have to do that in various notations, the best is to start with one that is the simplest for you. So, for example, if I think that simplest is to have syntax diagram, then I say, okay, these numbers can have sign. So I put here plus or minus or empty as a sign. Sign, and then you have to have at the end 0. So I'm going to put here 0. That is mandatory. You have to put it at the end. And in front of that, you can put any sequence of digits. So I put this digit in feedback loop. So you can have digit, digit, digit in this loop, any number of digits terminated by 0. So this diagram tells you exactly this syntax of object, syntax of this sequence of objects. Any one of them will be satisfied with this diagram, provided the digits are 0 through 9. If you want, you can put these digits here in feedback loop as parallel branches. And then you have the solution that is based only on terminal symbols, which is perfectly okay. But this is a little simpler, as you see, because if I put it in this way, then it is a little simpler. I have objects that can be decomposed into small units, not something that is very big. Now, if I want to write this in EBNF, then I say integer divisible by 10 equals plus or minus or empty, so it is in brackets here. And then after that, I have sequence 0 or 1, or not sequence, sorry. I have to select one of these and repeat any number of times. So I have the sequence where I have some prefix, and then comes after that 0. So you have that this repeats any number of times, and 0 comes after that. Now, this is by far the simplest possible notation. So it is simpler than this here. And if I have to do that in BNF, then I have to say integer divisible by 10 equals sign followed by value. So sign is plus or minus or empty. Empty is empty. Now, what is value? Value can be a single 0 or digits in front of that value, which means digit in front of value gives you something that is terminated with 0, because if it is a single digit, it is 0. And it has something, if it has something more than this single 0, then this is digit in front of that. So I can have here 1, 2, 3, and then at the end 0, because these digits are written in front of 0. So I have here 0, and then in front of it from the left-hand side, I can put any prefix of digits perfectly okay. For example, I can have 0, 0, 0. This is also divisible by 10, so no problem. And this is covered by this here diagram. So you can have 0, 0, 0, and 1 more 0 at the end. Perfectly okay. Now, you have to say what is digit. Digits is 0 through 9. So is this clear as 3 different ways to define syntax of integers divisible by 10? Any question that I could answer now? Okay, so let us assume that this is perfectly understandable. Similar question is this one here. Write the syntax of integer divisible by 50. So again, we have to see what is divisible by 50. Well, all numbers that have at the end 0, 0 or 50, like this one, 150. So you can have any sequence of digits, and then after that you have to have 50. Or you can have 0, 0. Or you can have as a singular point this single 0. So minus 100, minus 50, 0, 50, 100, 150, up to any number that has 50 or 0, 0 at the end. So the first thing that I'm going to do, I'm going to use EBNF. We'll say, okay, integer divisible by 50 can have an optional sign. So plus or minus is optional sign. It is in brackets, therefore you can use it or not use it. Then it can be as singular value, either 0, which is this 0 here, or all these numbers other than this 0. And all these numbers are here are an optional sequence of digits. So 0 through 9 optional, followed by 0, 0, or 50. So this can be nothing, 0, 0, or 50 at the end. This is going to perfectly work. So if you take this single line, you see that this is very, very simple. Actually, it is simpler than anything else. On the other hand, if you want to do that in form of syntax diagram, then you can say, I'm going to have a sign at the beginning, plus or minus or empty. Then from here, I can jump directly to this singular point 0 and go out. So this is this 0 here. Okay. Or I can go here and have 50 or 00, which is this suffix 50 or 00. That's perfectly okay. And I can have an optional sequence of digits that comes before that. So this optional sequence of digits has any number of digits that are repeated here. So I can have none, or I can have 1 if I go here, or I can have any number if I loop through this loop multiple times. Okay. So this is syntax diagram. Of course, digit is one of these digits, and this tells you all these integers divisible by 50. Now, BNF for that consists of definition integer divisible by 50, and you can say I have the sign and I have a value. So sign is this minus and value is this 100. Now, sign is plus, minus, or empty. Empty is empty. And what is the value? Value can be 0. This is the 0 here. Or these numbers that have some suffix, and in front of that you have a prefix, any number of digits. You can put here digit in front of suffix, or you can have that you have the prefix and suffix, where prefix is sequence of digits, so empty or prefix followed by digit, and suffix is 0, 0, or 50. So you can put 0, 0, or 50 as suffix, and in front of that, whatever you want, any prefix that you want, or a digit in front of this suffix, and any number of digits can be made in that way. Okay, any question about this? Now, let us go to study our last, fourth notation, which is parenthetic notation. Parenthetic notation was introduced for COBOL language in the 1960s, and COBOL stands for Common Business Oriented Language. Common Business Oriented Language is a very important language that was generating plenty of jobs, because the idea is that the language has to be rather similar to spoken English. So practically, it was possible to take, and also COBOL is working with variables that are usually monetary units. That means dollars and cents. So COBOL was a language for doing business applications. That means calculations with money and with database of various objects. So the idea was that you have files that can be supported in various ways, and COBOL is the most powerful language with file support. you can have that files consist of records, and these records can have tree structure can be very precisely structured to have components. For example, if you have a record that is driver license includes inside name and address and number. And then address contains number and street and whatever comes in. So you have object inside the object. And this is perfectly possible to define in a very elegant way in COBOL. Plus, COBOL was offering sequential files, relative files, and indexed files. So you have that each record can have key an index. So you can search a file by saying, this is a file of cars and give me all Volkswagens, for example. So go from Volkswagen to Volkswagen through that file. So practically you had that plenty of database operations for searching database like select statement or something like that can be done in COBOL in a very nice way, and in a way which is very close to spoken English. So since there is no much mathematics inside, it is a language for working with files and with money. Everybody who has high school education and one course of COBOL could be programmer. And this was generating thousands of well-paid jobs for people. So COBOL was language that was not something that needs university education. You need one nice course of COBOL that you take training in COBOL, and you have high school, and now you have job as a programmer. And after a couple of years, you become a very good programmer in COBOL and have stable income. And that is what COBOL contributed significantly to creating jobs. Now, it is combining graphic and analytic components. It has alternative objects that are written vertically, one above the other. So it has a little bit of graphical and a little bit of analytic things combined together, which is very good. You are going to see now that in a minute. And it is using braces and brackets. Braces are used for those things then have multiple options, but you have to take one of them. And brackets have multiple options which can be omitted. That means optional elements are written inside. Similar to EBNF. EBNF also use this for optional elements. So it is now having something that is different from other languages, and these are required and optional reserved words. So if you want to be close to spoken English, you have to have also possibility to have constructs that are close to spoken English, and you're going to see them in a minute. So another thing, you should not use recursion because it is very difficult to explain for people without mathematical education what is recursive function. So it is better to eliminate recursion. And that is what EBNF is doing, and this is what COBOL is doing as well. So who was in charge of that? Well, one very important contributor was Jean Summit. This is Jean Summit, one of 6 people who developed COBOL. So she also published in 1969 the book Programming Languages, History and Fundamentals. And that was extremely important book, and it was big book like this, had all developments for 1957 to 69. So for this first, let us say 10 years approximately of development of languages, there were plenty of languages that were developed, and she explained them in this book. So she was president of ACM from 74 to 76. And according to current estimate of IBM research, there are more than 2 billion lines of COBOL code that are now in use. And there are estimated 2 billion lines that are added or changed each year. So you can have, there are plenty of legacy software in COBOL. And of course, most of these business applications are not very quickly changing. If you compute tax is now similar to the tax that was many years ago. So if you have to compute a tax for a tax return, you can write that in COBOL in a very elegant way. So this is Jean Sammet, who contributed significantly to COBOL. And the other lady who was a big contributor was Grace Hopper. Grace Hopper is practically the first human who wrote the compiler. So she wrote the compiler in 1952. It was not for COBOL, it was for some language that she developed for solving some problems on first computers that US government had at that time. But she got the idea that it is necessary to write in some higher language and then translate that to machine language to make the life easier for programmers. And she wrote the first rudimentary compiler in 52. Now, she invented the word debugging. Debugging and debugger that we use today was not an English word before her. She introduced that word. So thank you, Grace. She was working for military, practically, and she influenced development of COBOL. She was not in the group who wrote compiler, but she was influencing that by requesting that the language should be close to spoken English. And she actually contributed to all these jobs that were created after that because programming was rather easy. And eventually she was US Navy Admiral. So she had the highest rank in Navy, and she was in charge, of course, of computers and similar things. So that's Grace Hopper and Jean Sammet. Two of them are extremely important contributors to development of languages and to compilers. Now, parenthetic notation, COBOL notation. What we have in COBOL? First, we have meta-linguistic variables, objects of the analyzed language. So if you have sign, you write it sign like this. So similarly to EBNF, you have that there is no need for angular brackets. You just say sign or unsigned integer or if statement or whatever you want to write just in lowercase. And denoted in lowercase without underlining. And their sequencing is denoted by simple concatenation. So you say, I have sign, and after that unsigned integer. Unsigned integer is 12, and sign is minus. So minus 12, 1, 2. Minus 1, 2. So you have sign and unsigned integer. Simple concatenation, you put one after the other. Now, exclusive OR is written by using pair of braces, and objects are written above each other. So if you have here first, second, third, fourth, that means you must take one of them. Which one? Whatever you want, but you have to take one of them. And these are options, first option, second, third, fourth. So this is like parallel branches in syntax diagram. So it is combination of graphical and analytic form. So you have here, for example, 1, 2, 3, 4. So if you have this inside braces, that means you must take one of them, either 1 or 2 or 3 or 4. So there are 4 options. And this is exclusive OR. Sometimes, very infrequently, this is written in this form, which is, of course, equivalent. But this is much better because you visually see that these are options where you have to select one of them. Is this clear? Any question? So this is exclusive OR. Now, you must take one of them. If you can omit this, then you have to write that inside brackets, same as in EBNF. So optional elements that can be omitted. So it is 0 or 1 instances of the objects inside the brackets. So that means you can take first or second or third or fourth or nothing. You can omit that if you want. So that is again visible visually by putting these things one above the other and then having to select one of them or omit all of them. Now, word delimiters, that means words that you use in specific language, are usually reserved. So they cannot be used as names of variables. They are mandatory, cannot be omitted. And in syntax definition, they are written in capital letters and they are underlined. Capital letters means that this is a reserved word. You must not name a variable with the word while. You must not name the variable with the word do. Do and while are reserved words. So they are required reserved words. Reserved are written in capital letter, and required means that you must use them as they are written. So while condition, do some statement. So while condition, compute tax and or whatever is here. So while do. Now, required reserved words are required and you must use them. But for readability, it is good to have words that can be also omitted. So in English, you say less than or equal to. So this than and to are necessary if you have correct expression in English. Less than or equal to 15, for example, or age less than or equal to 20, okay, or to 18. When can you drink beer? Less than or equal to something, you cannot. Above that, you can. So optional reserved words are reserved because this then and this to are reserved. You cannot have the variable named to because this would make ambiguity and be problem in compilation. So this is reserved word. However, they are not mandatory. So you can write less or equal without then, or you can say less or equal to. That would also be correct, or less than or equal to. So you have practically 4 possible ways how to write that. Less or equal, less than or equal, less or equal to, or less than or equal to. So all combinations are possible. Of course, when you write the compiler, this is a lot of work to take all these combinations into account. But from the standpoint of user, whatever the user writes, compiler will understand. So this then and to are optional words, optional. They are written in uppercase in syntax definition to say this is mandatory, you have to have them written in this way. So you cannot say here then with wrong spelling, like putting here E. This is not going to work. So less than or equal to. So it has to be correctly written, but it can be omitted. So these are optional reserved words. And this is good for syntax of other languages when you have things that are optional and are used for readability. Now, how to eliminate recursion? To eliminate recursion, you need to have possibility to repeat things multiple times, because recursion is defined for what reason? For repeating something multiple times. So in parenthetic notation, we used 3 dots. So if you have any kind of object and put 3 dots after that, that means that this object can repeat any number of times. So the previous syntactic unit followed by 3 dots will be repeated any number of times. So if I have 1 or more repetitions, I put this object in a pair of braces and say you can repeat now once or twice, or 3 times, or any number of times. If you want to have 0 or more, then you put in brackets and then put 3 dots after that to say you can omit this, or you can use 1 of them, or 2 of them, or 3 of them, or any number of them. So this eliminates the needs for recursion. For example, I have here one compute statement, and this compute statement is computing A, B, and C, these 3 different objects that are defined as X multiplied by Y. Okay, so X multiplied by Y will be computed and stored in A, stored in B, stored in C. So what you can define here as a syntax, that you have the keyword compute. So this is reserved word is compute. And then you have sequence of identifiers. So identifier 1, identifier 2, identifier 3. So identifier is inside brackets, and 3 dots say you repeat them any number of times. So compute A, B, C, etc. Now, what means rounded? Rounded can be omitted, but if you write it, it has to be written in this way. Obviously, all these identifiers will be identifiers of variables that are money, dollars and cents. So when you compute with money, for example, you go to grocery store and buy something for $15.35. And then you have to pay tax on that. And tax is 8.5%. So you take this amount, multiply by tax, and then you get the real number that has any number of decimal points. But you have to round that to dollars and cents. So if you want to round that, you have to say rounded to be rounded properly, not truncated. It can be truncated if you just cut to specific number of digits that is the size of available field, or you round that optionally. So identifier like this A must be defined as a field that has specific size. So it has fixed size, not an infinite size. So what we have here is medieval exception handling on size error imperative statement. So if you have size error, that means that the value that has to be stored inside that field cannot fit inside. For example, you reserved 6 digits, and now you have a big amount that has 7 or 8 digits and cannot fit inside. So this is size error. And then after imperative statement is either perform some recovery operation or stop run. Stop run is just terminate the program, and that's it. You have fatal error, you cannot continue. 2 more things that are important here. COBOL understood that each statement must have the end, because this statement is like an expression that has the beginning and end. So if you have here compute, you can put optionally and compute at the end to say this is the beginning and end, that you have left and right parentheses of what you are doing. This idea is tragically missing in C, C++, Java, and similar languages that don't have end of if statement. So you say, for example, if, and then after that you put condition in unnecessary parentheses, and then after that you have pair of braces and something inside. The right way to do that is to say if condition, then expression, else another expression, and if. If you do that, then you have no need for writing braces. And you eliminate gazillion of braces that we write in C, C++, Java, and similar languages. So if, then, else, and if is the right way of doing that. But not all languages have that. In the case of COBOL, COBOL has this compute and compute, and therefore this is a good thing to have beginning and the end of statement. This is optional. You don't have to put it. But if you put it, then you have left and right parentheses of your construct. And then you know what is going to be returned from there. Something is returned. Another thing that I want also to mention here is this multiplication. Now, in COBOL, you can have the name of variable. For example, total amount. These are two words, and it is written total, and then put here hyphen amount. So if you have variable that is called total amount, the problem is that the language was introduced at the time when keyboards were small and don't have underscore. So COBOL decided that you can have multi-word identifier that are hyphened with minus sign. So it is like total hyphen amount. Well, this is nice, readable, understandable, whatever you want. But how to write minus? Because if this is total minus amount, then how to interpret this? And COBOL had obvious, simple solution that if you want this a hyphen here to be minus, then you have to put one space before and space after that. If you do that, then you have total space minus space amount, and this is operator. And therefore, the habit that is developed from that time is that it is good to put little space before and after this operator multiplication. So when you write multiply, put space before and put space after. Otherwise, it is not going to be understood by classical COBOL. Now, one thing that we have to say immediately is that even today, it is a very good habit that you put a little bit space before and after an operator. So if you have an expression plus another expression, it is very good to put little space before, plus, and after so that it is readable for the guy who has to read that and understood. It is always good to have little space. Now, these A, B, C are also separated by space. So we have three objects, A and B and C, and each of them is instantiated with X times Y. And there is space that is mandatory before and after this multiplication. Now, this is readable, this is trivial, this is whatever you want. But like I said, in my opinion, it is a good habit to have a little bit space before operators for readability. Of course, compiler doesn't care for spaces, but if you put just no space, then it is more difficult from reading than if you have space, and it is easier to see what are components that you have there. Do you remember this example that we had when we said letter is A or B, digit is 1 or 2 or 3, and variable is letter followed by digit 5 digit? Well, if you want to write that in parenthetic notation, then you have here A or B, followed by 1 or 3 or 5, followed by 1 or 3 or 5. Now, this here is extremely readable. Trivial, you know that you have a variable that must have the name starting with A or B, that after that you can have digit 1 or 3 or 5, and after that 1 or 3 or 5. So to create 3 times 3 times 2, 18 different combinations this here. And this is very, very readable. This is the first component, second, third. They come concatenated one after the other, and each of them is selected from here. And each of them must be taken. So you must take one of these 1, 3, 5, and one of these 1, 3, 5, and one of these A or B. Here is another example. We have that with 3 dots, we can repeat previous object any number of times. So here is add operation, add A, B, C, and 123 to X and to Y. So this is first amount, second amount, third amount, fourth amount and add these both to X and to Y. So you have to pay A plus B plus C plus 123 to company X and to company Y. So add A, B, C 123 to X and Y. How to write that? You have here add. Identifier is A or B or C. Literal is a constant value. Literal means either a character constant or numerical constant. So 123 is literal. 2, any sequence of identifiers. You can add any sequence of identifiers. So literals to any sequence of identifiers, and you can round that if you want. If you want to have money that is rounded, otherwise it is going to be truncated. If it is truncated, it is always going to be less than necessary. If it is rounded, then it is going to be more accurate. So if you have 19.9 cents, you are going to have 20 cents, not 19 cents. So it is going to be more accurate. On size error, which can be used or not used, is exception handling. So if you have size error, perform this operation here to recover from that. If you don't do that, if you have size error, the program will break because cannot perform that operation, and you will have that the program stops working. So it is better to have exception handling so that you can do this exception. Also optional, you can say this is add and this is end of addition. So from add to end add. If you don't put it, it is also okay. So this is this add ABC 1, 2, 3 to XY, and you have dot at the end. So that's perfectly okay. The second example here is with giving. So you can say add A, B, C to D, giving the result that is stored in X and Y. So add A, B, C to this value D, which can be a literal, giving the result that is stored in X and stored in Y. So add identifier 1, literal 1, and so on and so forth, to another single object. So this is the single object, giving this sequence of results that can be rounded if you want optionally. So you can have X rounded Y. So X is going to be rounded, Y is going to be used directly. And then on size error, which I don't use here because it is optional, stop run. If you cannot continue in that way, stop run, and that's it. Another thing that is interesting here is that this notation that has visual form makes it easier to use. For example, if statement. If identifier or arithmetic expression is or is not positive or negative or 0. So you see how many combinations you have. You have here identifier, any identifier A or B or C or a hex, or arithmetic expression. So you can say if A plus B is not negative, then do something, okay? So by reading this, you see directly all options that you can have. So after if, you can have identifier or arithmetic expression. Then you must use either not, or is not, or is, which is optional, okay? And then here you have positive, negative, 0. So for example, you can say if A 0. This is ugly. But if you say if A is 0, that's better. Or if A plus B is not negative, perform something. So it looks as a spoken English, it is understandable to everybody, and a native speaker find that very easy for them because it is the way how they speak. If condition 1 and or condition 2 and or condition 3 and or condition 4, you can have any number of them. These 3 dots say that you make expression that is condition 1. So if A greater than 0 and B less than 3 and C equals 0, then perform something. Here, if identifier is or is not numeric, alphabetic, uppercase, lowercase. So you can test whether an identifier is numeric, that means a number, or alphabetic, that means a character string, or uppercase or lowercase, and then perform something. Here is an example of relations, plenty of them. So you can say if something is not greater than this way, is not less than, is not less than in this way. So you can have here 10 different possibilities to say the same thing, similar thing. So to make relation. Of course, is not greater than or equal to is exactly the way how you do that in spoken English. Okay, but you can also write as greater than or equal to. So this is example of relations. This is an example of exam where you have a theoretical question, explain parenthetic notation. And then, of course, in online case, we cannot have these kind of questions, but you simply say, I have metalinguistic variables, exclusive word, optional elements, required reserved word, optional reserved word, and 3 dots, and give an example. Another example, an equivalence between BNF notation and parenthetic notation. So I have if condition and or condition, any number of them, then statement, all statement. And then you can have in equivalent BNF, operator is and or, and then compound statement is condition and or compounds condition and or condition, etc., etc. Else can be omitted, empty, or else statement. And then if statement, if compound condition, then statement else part. So this here is equivalent to this here. So, and finally, one exam that we have directly here, writes BNF, EBNF, syntax diagram, and parenthetic notation of the syntax of exponential real numbers. So you first write BNF, then you write EBNF, then you write syntax diagram, and then you write parenthetic notation. What is the simplest? Well, if you compare these 4 things that are completely equivalent, in my opinion, this one is the best, because exponential values, for example, plus or minus 1, 2.34 times 10 to minus 12, or this here times 10 to minus 7, can be explained in this way. You have an optional sign, plus or minus or omitted. And then the number can be written as integer or like 5, or 0.5 as 1/2, or 5 point to make a real number, or 5.5, for example. So these are all possible ways how we can write number. And then you must have E, and after that optional plus minus digits. So digits are 0, 1 through 9 that repeat any number of times. So this is visualized. It is perfectly written how it is concatenated and what are the options inside. So this is very, very simple to understand. If you have to write syntax diagram, you can do that in various ways. These are the most readable way, but still you have plus or minus, sequence of digits, then you have dot, maybe optional sequence of digits, then you must have E and exponential part. You can have also point and some digits after that. So you can skip this if you want, these leading digits. So this and these are 2 equivalent way, and you can have more than 2 of them. All others that I have are very ugly, and I don't want to show you. And then, for example, for BNF and EBNF, you do that in standard way. Digits are digits in front of digit, and sign is plus or minus or empty. And then you have sign, digits, and exponential part here. Same in this case. So in this way, we have finished our study of basic 4 notations for syntax of programming languages, which is BNF, EBNF, syntax diagrams, and parenthetic notations. All these 4 notations are equivalent, can express the same thing in 4 of them. Sometimes some expression is simpler, some expression is more complex, one of them. So we are going to have homework that is going to be posted most likely tomorrow or something like that. And then you are going to have 2 weeks to practice a little bit this. On Monday is Labor Day. So we are not going to have the class, but we are going to have the class next Wednesday. And next Wednesday, I think that I'm not going to go to procedural programming, but I'm going to still say something about a connection between syntax and semantics using slides from Weber's textbook. So that's my plan for next Wednesday. Between now and next Wednesday, you should practically spend time to learn these 4 notations. And you have to spend some time to have a clear understanding how they differ and to try to do some example yourself. Is there any question that I can answer now? If no questions, thank you very much for attending. There were some moments 75 people, and then it was going down up to 63 that are currently here. If there is something that you want to discuss or ask longer questions or something like that, feel free to come during office hours, which is from 1 to 2 today.